In population ecology, there are a few key diagrams that you want to be familiar with. So the first one is the distribution of a population. So the most common one is this one over here, and that is clumped. They are clumped around the resources that they need. Now, random and uniform have two things in common. That is that their environment is fairly continuous, it's the same. But in random, there is low competition, and in uniform, there is high competition. There are two different growth curves, and it's population density per time. So the one here in red with the J-shaped growth curve is called an exponential growth curve. It's a factor of just your R, which is your birth rate minus your death rate, times your population size. These are usually very small organisms. They are eat, drink for tomorrow, we may die, as opposed to a logistic growth curve or an S-shaped growth curve, which is a factor of your carrying capacity. Now, where we already saw the growth curve, these are survivorship curves. What are the likelihood that you are going to survive to reproduce? So there are three types. What they all have in common is they start at 1,000, right, per capita. And so type 1 are usually large organisms. They make very few offspring, and they live out their lifespan. The opposite of that is type 3. This is closer to the J-shaped growth curve, and you make a lot of offspring. You're not planning on all of them making it. And then in between would be type 2. So you can take all that information, and the two extremes are R-selected species and K-selected species. When you look at these R-selected species, these are very small organisms. K-selected, more about the carrying capacity. These are larger organisms. Let me give you a chart to compare them more. So for the R-selected species, they have a really unpredictable climate. That's why they're taking advantage of the moment. Most of the factors that regulate R-selected species are density independent, things like tornadoes or drought or weather. Their survivorship is usually type 1, and they're more colonizers than competitors. They start early, make a lot of offspring, and have a very short lifespan. Whereas K-selected species are the opposite of that. They have a constant environment. Factors like density-dependent factors like competition and disease regulate them. They usually are a type 1 survivorship curve. They are regulated to their carrying capacity. They are competitors over colonizers. Age structure diagrams, you have pre-reproductive in blue, reproductive in yellow, and then orange is post-reproductive. When you have a large base, that population is going to grow. When you have a smaller base, it's probably more stable, and you can have demographic changes, and you can go from an LDC to an MDC.